Welcome to the walkthrough for Assignment 1A. The purpose of the first part of this two-part assignment is to deepen your experience using Java's functional programming features and their integration with Java sequential streams. In particular, in this assignment, you'll develop an app that uses Java sequential streams to obtain, transform, and store images. The code you write for this assignment has a GUI and runs as an Android app. Please feel free to use this app to help debug your solution. The following resources may be helpful in completing this assignment successfully. They're good overviews of Java streams that appear here and here, and the book Modern Java in Action is a great resource to learn how to program Java streams. Naturally, we'll cover this material in class, which will be available in my YouTube CS253 playlist. The Image Crawler app is packaged as a project using Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1A, however, you only need to be aware of the following directories. Image Crawler crawlers, which contains the skeletons you need to fill in, as described below. Image Crawler source test, which is a set of unit tests that exercise the features you're implementing to evaluate whether you've correctly satisfied this assignment's requirements, and app source Android test Java assignment tests, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which would automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to select an emulator that uses an API greater than or equal to 29. I recommend using API 30. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeletal Java code by completing the to-do you fill in here tasks to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks, and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Image Crawler crawlers folder. Focusing first on sequential streams crawler.java, you need to complete the to-do tasks in various methods in this file to obtain, transform, and store images. This class uses Java sequential streams to perform an image crawl starting from a root URI. Depending on the parameters used to run the tests, images from HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored in the local file system on the Android device. The bulk of the code for this app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the sequential loops crawler.java file. You'll therefore focus on converting this Java 7 based class to the sequential streams crawler class that uses Java sequential streams. Your solution should use no loops or if-else statements in this assignment, and instead use Java sequential stream aggregate operations. Your solution will be considered correct if it passes all the unit and instrumentation tests. Skeleton code for this assignment is available here in my GitHub repository. Please set up your GitLab account, pull the skeleton code into your repository, read it carefully, and complete the to-do markers. Unit tests are provided to increase our confidence that your implementation is working as expected. You need to learn how to use the Android Studio GUI to run the unit tests locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, not their absence. So don't rely solely on the unit test to detect problems in your code. Assignment 1A is designed to deepen your experience developing apps using Java functional programming features and Java sequential streams. In particular, the skeletons and unit tests are quite extensive, though you don't need to understand them all to complete your solution. Please therefore start early and ask questions in class, office hours, and on the discussion forums to ensure you complete this assignment successfully. Now that we've walked through the specification for Assignment 1A, it's time to turn our attention to the skeletons. If you open up the Android Studio project, which you can get from my GitHub repository, you'll find the following path: image crawler, source main, Java edu Vanderbilt image crawler crawlers. And there are two files here we're going to take a quick look at. The first is called Sequential Loop Crawler. And Sequential Loops Crawler is an implementation that uses only Java 7 features to perform an image crawl, starting from a particular root URI, which would typically be some folder in a web page. Images from the HTML page that are reachable from the root URI will be downloaded either from a remote web server, if that's where they're stored, or there's also a version that can be getting those files from the local file system. In either case, the results will be stored in files that are local to the device and then have those files displayed to the user. This implementation is entirely sequential and uses no Java 8 features at all. It therefore serves as a baseline for which we'll compare all the other implementation strategies we'll be doing in this class. And you can read this link if you're interested in seeing how you could write a web crawler using the JSoup HTML processing library. So let's take a look first at the perform crawl method. This is the entry point into this particular strategy. And what it'll do is it'll recursively crawl the page that's passed as a parameter called page URI, and it'll return the total number of processed images that were encountered during the crawl. You'll also see that there's a depth field here that keeps track of how far down you're willing to go in the hierarchy of folders before you bail out. And this is here primarily to avoid infinite recursion if you have loops in your folder hierarchy. First thing we're going to do is check to see if the depth is greater than this max depth constant, and that's something that can be set either by default or by an option that could be set when the program started to run. And again, basically that's just there to limit the depth of the crawl. The next thing we do is we use the putifAbsent method on the mUnique URI's hash set object. And this is a cool method that implements what's called atomic check then act semantics. A little overkill here because we're not doing concurrent programming, but basically what it's doing is it's adding the page URI to the hash set, or it's trying to add it to the hash set. If it's already there, that means we've visited this page before, in which case we're going to return 0. If we haven't visited this page, we'll stash this away so that subsequently we will not visit the page if we come here through another path through a recursive traversal. The last method we call is known as crawl page, and this is a helper method that recursively crawls all the images and hyperlinks on this page and will return the total number of processed images. So let's take a look at the implementation of crawl page. This also uses Java 7 features to download and process images on this page, if there are some there, via the process image helper method. And it will also recursively crawl other hyperlinks accessible from this page, if there are any, by calling perform crawl. That's the method we just looked at. And finally, it'll return a sum of all the image counts. So you can see what we do here is we start off by calling the getPage method, which will go out and fetch the HTML that's associated with this page URI. So now we've got ourselves a page. And there's a couple of different paths through the code. Let's take a look at the undergrad version here. We're going to initialize a one-element array to do some clever tricks with lambda expressions. I'll talk about this in class if you're curious. But basically what we're going to do then is we're going to go ahead and use this helper method to get all the hyperlinks and images on this particular page. And so by calling it in the way that we're doing here, it's going to return all those elements. And what we then do is for each of those elements that get returned, we're going to check to see whether the element type is an image or a page, which is what else is. If it's an image, we're going to call process image, which will then process the image. We'll take a look at what that does in a second. If it's a page, in other words, if it's another web page that's linked from this page, we're going to recursively call the perform crawl method. And that will then go back and start over again with this URL as the new entry point URI for that recursive call. So we've already seen perform crawl. Let's take a look at process image. Here's process image. You can see it's going to process an image by applying any transformations that have not already been applied and cached previously. So here's how this is going to work. We're going to take the URI here, and we're going to go ahead and call get or download image, which is a helper method that will get you back an image. If you give it a URL that makes no sense, it'll of course return 0, in which case you bail out. But assuming that doesn't happen, then down here, we're going to go through each of the transforms, and each of these transforms does a different image processing algorithm, like grayscale or sepia or tint or whatever. And for each transform, we're going to go ahead and call the create new cache item helper method, which will attempt to create a new cache item for this transform. And then, as we'll see, it'll next call another method called apply transform. But if we've already applied the transform and cached it earlier, create new cache will simply ignore it. So don't worry about that. That does things for you automatically behind the scenes. So assuming that you have to perform a transform because it hasn't been done before, the apply transform method gets called, and that will apply the transform to the image. And then we increment the count to indicate there's one more transformed image. And when we're all done going through this for each iteration, we're going to go ahead and return the count of the images. And that, of course, will get passed back up here as the return value of process image, which will then be used to store here. And then when we're done, we return the number of processed images. So that's essentially the flow of the non-streams version of this code. And so you should take a careful look at this so you get a sense of what helper methods to call when you implement this with streams. So now let's turn our attention to the sequential streams crawler. And this, of course, is the one that you have to implement. The semantics are the same as before. It's doing an image crawl. The difference, of course, is it's using Java sequential streams instead of Java 7 features. Here's the entry point method. Looks very much like the one we did before in terms of the signature. You take the page URI and the depth. But then it does some other stuff. And this is kind of clever. You're going to have to think about this a little bit. I've kind of given you a high-level description of what is supposed to happen, and I'll give you some hints as I talk about this. So you'll use a factory method that's available on the stream interface in order to create a one-element stream that just contains the page URI. So you'll have to think about how to do that. It's pretty simple, but you'll have to think about how to do that. Then you'll use the intermediate operation filter to filter out the page URI if the depth is exceeded or if you've already visited this page. And so you'll have to go back and take a look at the Java 7 version to see sort of what is done there. Next, you use another intermediate operation in order to recursively crawl all the images and hyperlinks on this page and return the total number of processed images. And in this particular case, what you're going to do is call the helper method called crawl page. And you, of course, want to do that with an intermediate operation that will perform the processing and then return the results. So you'll have to think about what that operation should be. And then the final thing you'll do here is you'll use a terminal operation that will be used to extract the total number of processed images from the one element stream. And there's a couple of different ways to do this. There's a really simple way to do it using a terminal operation. I'll give you a hint. It starts with find, although there's more to it. And that will return you an optional, and then you'll have to use the or else method to return 0 if the optional is empty. The optional should not be empty, by the way, but that's just for syntactic reasons you have to do that. So we're now going to talk about the crawl page method. This is the method that's called from the perform crawl method that we just talked about, and it uses Java streams to download and process images on this page using process image, and then recursively crawl the other hyperlinks available from this page via perform crawl, and then it'll return a sum of all the image counts. And this implementation will differ from the one we looked at earlier because it's going to use Java sequential streams. So the first thing you'll do is you'll use the getPage method to get the HTML page associated with the page URI. That's actually very much like what we did in the previous example. And then from that, we'll go ahead and make sure the page is non-null. And then we'll use the getPageElements method on the page in order to be able to get the list of all the image and page links on this page. And at that point, then streams sort of kicks in. So we're going to convert that list into a sequential stream by using a factor method. And then we're going to use another method that are talked about in the videos and the class discussions to map each web element into the count of images that are produced either by processing an image or by crawling a page. So you'll either process an image or you'll crawl the page. And again, take a look at the Java 7 version to get a sense of how you might do that. And then the final thing you'll do, still part of the stream, is you'll sum all the counts together. So let's now go ahead and take a look at process image. Process image is the method that gets called when you want to process an image by applying any transforms that have not already been applied and cached. Now, again, some of this is going to look a little bit like what you would do for the previous version. You'll call the method that will download an image, get or download an image, and then you'll bail out if that returns null. But then after that point, things are going to be stream oriented. So you'll take the list of, or the list that you have of transforms, and you'll convert that transform list into a stream. And then you're going to go ahead and try to create a new cached image for each transform, skipping any that are already cached. And I'll give you a hint. This is where you want to use the filter operation that's defined in order to be able to remove things that don't have the results you want. So for example, if you try to create a cached image and there's already one there, or you try to apply the transform and you get back a null, then you want to skip anything in that case. So filter is what you want to do there. And so you could do a couple different ways, but I recommend you use one filter call with sort of a compound expression inside there to make sure that you return false if things don't go your way, and only return true if you're able to actually do the transforms properly on non-cached images. And then the final thing you'll do here is you'll return a count of the number of transformed images. And you have to be careful here because you don't want to be counting any images that fail to download or transform correctly. And the unit tests will actually intentionally have things fail. So in that particular case, you want to make sure that you don't count those things. So you'll have to make sure that your filter expression will eliminate anything that didn't work properly. So you return the count from that, and then that, of course, will get percolated back up to this stream that you wrote here for crawl page, and then ultimately that will all get percolated back up here to perform crawl. And of course, there'll also be, like I mentioned before, a recursive call to perform crawl inside of crawl page if you happen to visit an HTML page that itself has other links and so on the page. So that's basically a walk through the skeletons. It's really not that hard. It just takes a little bit of time to think about how to express the logic using Java streams, sequential streams in this case, which will have very few, if any, if statements or loops. There could be an if statement a couple places if you want to check to see if something was null when you make calls that return null, like get or download image. You might want to have an if statement after that to return null. And likewise, when you call get page on the web page crawler, you could also have an if statement there. But other than that, you really should try to avoid if statements, and you definitely don't want to have any loops. So that's the end of the walkthrough of the skeletons for this assignment. Now that we've walked through the specification and the skeletons, it's time to show how to run the unit tests. If you go into Android Studio and click the Gradle tab on the right-hand part of the IDE, you'll see a set of tasks. What you want to do is typically go over here and click on the Run Unit Tests Tasks, which is in the Auto Grader portion. So if you go here, you can see there's Tasks, there's Auto Grader, and then Run Unit Tests. And that will start the unit tests. Now, these tests will do quite a bit of analysis of your code using very sophisticated mocking techniques. Actually, they're written in Kotlin of all things, but that doesn't really matter because we don't give out the source code for the tests. We just give you the jar file that contains the tests. And when you click on this, it'll go ahead and run all the unit tests on your code. The tests take a while to compile and run, so I'm going to kind of speed things up and go to the end and show you what things should look like if all goes well. You can see the unit tests are starting to run now. There are 13 unit tests that are run, and you can see here that the way it works is if you get everything working, it'll tell you that how many tests passed, how many tests failed. In this particular case, we had 12 out of the 12 tests run. You can ignore one of the unit tests that gets skipped. And so if everything goes well, you should get 12 out of 12. If something goes wrong, then it'll tell you kind of what went wrong. You get a back trace of the stack. And of course, sometimes it's a little confusing to know what's happening. So if you have failures that you can't figure out, please don't hesitate to contact us in office hours or through Piazza, and we'll help you track them down. The unit tests do things that are kind of looking for how you write your code. It's not just looking at black box execution. It's also looking at the order in which you call the operations for the streams, whether you're passing in the right parameters. And of course, the tests aren't infallible, so you can still have bugs in your code. And that's why I do a manual review of all your solutions and give you feedback so that you can make sure that between my review and the unit tests, you can do as well as you possibly can.